all the participants, my team, and all the IT unit who conducting this important webinar on that particular issue, that is the utilization of geospatial technology in the Python sector. So I think, as you know, that if you go to the website of RSIGST, you find that RSIGST is one of the geospatial center of excellence, which is working not only independently, but obviously in collaboration with the different central and state government organizations, industrial partners. And this is not just a new to us, because already we have been conducting more than 200 webinars on the different issues. And obviously the Python is one of the pioneer platform which we utilize. And hopefully after this webinar, we are going to announce somehow course. We are looking forward to start from the, I think, end of this month, or like from this month also, regarding the application of Python and GIS. So I'll be very happy to invite all of you to participate in this course. And it is also an application model. I think 3 months course we are going to organize, and this will be, I think, the 7th or 8th batch we are going to organize. So besides that, the participants, those who have joined from the different corners of our country as well as other parts, so we'll be very happy to invite you to connect with RSI GST in different capacity building mode, research collaboration, or any way where you could involve in the application of the GIS for the societal benefit or the climate action or environmental sustainability, disaster management in any way. So this is the platform. I am saying, always saying that RSI GST is the cloud-based platform. Anybody can come, can contribute for the society, for the knowledge expansion and all that. And hopefully in coming future, if any kind of project could be generated in association with your expertise or with us, obviously through that we will try to materialize that project in collaboration with you, so that some job opportunities will also be created and some project consultancy part will also be developed. So with this, I will not extend my points very well. I think you have gone through the RSI GST portal, RSI GST website, RSI GST social media platforms. So please keep in touch with us for our more upcoming initiatives, and please join us in future as well. And once again, I congratulate to Mr. Goipan Ghosh, our team, Antika ma'am, for conducting this important webinar for the understanding and the application of the Python, which is very important in case of the coding geospatial application sector. So let's move ahead with this initiative, and we look forward to your heartfelt participation. And obviously, if you think that it is ultimately helpful for you, your knowledge benefit or any other's benefit, it could be, you please share this initiative to others, and so that people will get to know more and more about it, and they could connect us, and we got the opportunity to serve them. So thank you. Over to you, Deepan. Thanks for the opportunity and best wishes to all of you.
Thank you, sir, for your welcoming words. So it is my absolute pleasure to introduce today's distinguished speaker, Mr. Krishna G. Lodha. Mr. Lodha is a highly regarded geospatial professional and educator, recognized for his deep expertise in the intersection of Python programming and GIS. He is the founder of Rotten Grapes Private Limited, a platform dedicated to empowering learners and practitioners with accessible, high-quality geospatial programming resources. With hands-on experience across open-source GIS technologies, Python geospatial libraries, and a track record of building GIS solutions that bridge science society, Mr. Lodha has become a go-to voice in the geospatial community, especially for those looking to integrate automation and data science in their spatial workflows. Beyond this technical acumen, Krishna is a passionate mentor and advocate for open learning, helping thousands of learners and professionals upskill in geospatial analytics through webinars, courses, and content creation. We are honored to have him here today to share his insights on transforming GIS with Python integration. Please join me in warmly welcoming Mr. Krishna Lodha.
Thank you, Vipayan. I hope you guys can hear me fine.
Yes, sir. Yes, sir. Absolutely.
Great. Thanks a lot for inviting me. This is an absolute pleasure to talk about geospatial and with Python all the time. I feel that these kinds of talks enables more and more developers as well as the geospatial students to kind of like think in the direction that whatever they are doing, how can they automate it? And I think picking up Python is absolutely very amazing choice if you are not, let's say, from a programming background, because it enables you to obviously do things, but more importantly it enables you to start think like a programmer. Because when you get familiarized with these concepts of oops and things like that, you actually start thinking about the building blocks of how exactly you can write the programs. And then from there, it's not a very hard journey to think about what kind of activities you're doing on a day-to-day basis. Maybe you're using QGIS, ArcGIS, any kind of applications, let's say a software solution, not a web application, but like a proper installable softwares. And then you can start thinking that, okay, what might be the correct way that I can automate this and kind of like either improve the accuracy, or I can reduce the time that I'm investing right now to do certain kinds of things. Majority of the times when I give this particular talk, the audience is the audience consists of the geospatial analysts or students who have not heard about programming or something like that. And during that time, like when I talk with such people, there's one major challenge that they face, which is like like we are not from programming background, so how do we go ahead with it? Like we absolutely have no formal education for programming and all. A few years ago, it was very difficult question to solve, but still it was solvable. Of course, we thanks a lot to YouTube, which is in our service for now decades now, where we can practically find videos for every single thing that is out there. But now, thanks to the LLMs, ChatGPT, and the war going on with Sam Altman and Mark Zuckerberg, now for them, they are trying to just provide us as great resources as possible for as less cost as possible. So I think now it's much more easier, and that that excuse that you want to give, that hey, I'm not from a programming background, how do I do it, is not relevant anymore. And how can I say this is from my own experience, because I'm trying to learn a couple of things nowadays, which again I have no formal education in, but I'm just trying to ask ChatGPT, take use of Claude AI for writing the code, and it's working great. Certainly, there is a pro and con of doing this. Doing this is obviously, like, if you don't understand what is happening behind the scenes, it might be very hard to debug, and you will end up having a code which will probably not work all the time. But certainly that can help you to kind of like go ahead. So that's all that I wanted to give as an intro. I have a very small presentation slides that I wanted to go through, and probably I want to keep floor open for more like a discussion, because um, not like like 40 minutes of series or probably webinar probably won't be enough to cover the entire Python thing. But I am more than happy to at least give you the idea that what is something that you can search after this webinar online to get started with. So that would be the idea. At any point of time, if anyone has any question, feel free to raise the hand, or I'm not sure how the logistics are, or maybe you can just unmute yourself and ask me the question. With that, let's get started. So also, I will put the link of this presentation online. All of my presentations are available online, so you can watch them anytime. And the reason why I keep it online is I keep on improving these presentations as and when it's possible. So you can always refer to this and get the latest info. Yeah, I think someone was speaking.
Yes, sir. There will be a Q&A session after your like speaking.
Perfect. Perfect. That's great. Yeah. So the topic that we have at our hand is Python for the geospatial revolution. So now when we talk about geospatial revolution, there are so many directions to it. You can actually categorize it as a web-based solution. You can have as an analyst solution. You can have as a data storage solution, etc., etc. Geospatial is probably is there in every single domain that you pick up, and that's why the revolution is happening in every single field. Few years ago, it was unimaginable to kind of like have a 500 GB or 1 TB worth of raster file, and we should be able to load it at a warp speed. And now it's something that we can take for granted, and this is how the revolution has been happening. With the more and more data available every single day, thanks to all the space agencies working throughout the planet, We have been loaded with petabytes of data every single day, which means that it's our responsibility as a consumer, to understand what might be the best way to consume this data and then make the analytics out of it. Because I'm pretty sure we all have heard about that data is the new oil, but in this moment or at this particular situation, the analysis is the new oil. Just having the raw data is not going to do any good for you. And that's exactly why you pick up any satellite company, they are trying to come up with the products and use cases where they are not actually trying to sell you the raw data, but they're trying to sell you the analysis based on that data. Now, this analysis again can be urban based, can be climate based, or anything like that. But the real question that they are trying to solve is that not trying to pitch you the data, because like for example, if you want to procure a data, there are like hundreds of providers. But what people are trying to do is like, how can I give you analysis or an additional thing on top of data? And that's where I think Python really makes a huge difference, because it takes care of the lot of backend processing happening for this data. We are living in a world where now Python codes are also being run in a satellite itself to do the processing even before that data hits to the earth. So that's amazing. That's a really kick-ass technology that is out there. uh, and yeah, so welcome to the world of geospatial Python. So we will have a look at why Python for GIS, popular Python libraries in GIS, and future pathways, Geo AI and cloud. So I think this is the popular Python libraries in GIS is where I would like to spend more time, because I would like to introduce you to the libraries and just give kind of like a use case. And the reason why I want to spend more time over here is because we all are working with different problem statements and different domains. What really makes sense is to understand the technology rather than just that one particular kind of like a use case, because if you understand the underlying technology, you can use it in potentially n number of use cases. So I would be spending more time in exploring and also letting you know that which Python libraries that I personally also use. Um yeah. So why Python in geospatial world? Essentially, you can consider that Python is kind of like a glue between the data analysis and a map making. So let's consider this, that you're procuring data. Now this data procurement can happen, let's say via satellite or any other remote sensing mean, or this might be a data that you are creating from the ground, or this might be a data that you are kind of like a digitizing, let's say the cadastral maps or something like that. So you have n number of data sets. We are living in a world where we have vector data, where we have raster data, where we have point cloud data, spatial data, etc., etc. There are so many types of data sets, each having its own pros, cons, use cases. And then second is the analysis. So it doesn't matter if I give you, let's say, let's say the RGB plus NIR imagery, a multiband imagery of the entire India. If you want to do some analysis on top of that, you need to understand the logic behind how exactly can I use the pixel values on each particular pixel of the raster, so that I can do some kind of prediction out of it or some kind of analysis out of it. Maybe you are interested into finding out the vegetation index values like NDVI or EVI or something like that. That's where you will need a tool which can help you to do the analysis. And last but not least is the map making. The analysis which cannot be presented to a non-tech people is almost a wasted analysis. So you need a solution which will also allow you to kind of like expose this and make it available for a non-tech people, so that they can make some sense out of it. A very simple example I will give you, what we are doing with one of our product known as Observer is kind of like so we have created an API as a service which is purely built on Python, where it is helping agri-tech startups and insurance sector startups who are focusing on the agri and forestry to actually get the map making done. So for example, everyone knows that Sentinels and Landsat and Modis are very good with providing a raw data with almost no cost. And then everyone also knows that, okay, you can do NDVI, you can do EVI, you can do fire burn indices, etc., using these data sets. But what really matters to, let's say, insurance companies or even to the farmers is the advisories that you will be bringing on top of these analysis. And that's exactly where we are trying to jump in. We are working with multiple agri-tech startups where we are providing them the data and the analysis, whereas they are taking care of the map making part of it. And the reason why we have divided these roles is because we can then purely focus on getting as much data and as quickly the data possible to you, thanks to fast API, again a Python based framework. Whereas then startups who are like kind of like a subject expert can focus on their own and create their own advisories or create their own kind of like a let's say decisions based on these data sets. So, and I think that's why Python is such an important thing in the geospatial world, because there are the ecosystem is so good that you have almost packages available or some kind of functionalities available for almost every single problem that is out there. It is open source, of course, at its heart, it's open source, it is extensible, and it is a community driven. Extensible meaning that there are so many plugins, there are so many frameworks available around Python. As I said, that for every single problem, there is almost a solution available in Python. And if there is no solution, you can actually combine multiple solutions together to get the solution that you want. And more importantly is that it is community driven. So there is nothing kind of like, you have to pay in order to get the access, or you have to subscribe in order to kind of like, get the question. It is community driven. You can just go to Stack Overflow, GitHub, anywhere, and you can just push your question, and then there will be someone who will be happy to answer your question. That's because the community around Python is very big. Easy integration with data science, ML, and automation. So I'm pretty sure everyone of you have heard about AI, and then there are a lot of models that are let's say geocentric, which you can use with satellite data, etc. Most of this model, majority of this development is happening around Python, because this is built on top of PyTorch, TensorFlow, Keras, etc., which are all easily integrated with Python, meaning that even if you want to jump into AI ML in the future, you will have to understand Python. And I believe that if you want to get into the AI ML, you should understand Python, because as I said in the very beginning, that learning Python will allow you to start thinking like a programmer, and it will open a lot of that thinking mode for your own. So absolutely, it's important to learn it. And dominant in a modern GIS workflow. So it doesn't matter if you are sticking with open source geospatial, or if you're going with enterprise solutions like Esri, FME, Google Earth Engine, or anything like that. Every single company out there has an SDK available for Python. It is that much famous. So even if you are using Esri, you can always learn ArcGIS API for Python. If you want to if you want to work with ArcGIS Online, or if you want to use the analysis functions available in Esri, you can use ArcPy. If you're using QGIS, then there is PyQGIS. If you're using Google Earth Engine, there is again a Google Earth Engine Python API. And if you're using FOSS, like us, what we do at our company, there are n number of products available. Now let's understand more about the top geospatial libraries that are available in Python. So when I mention top, it doesn't mean that they are the best and they can be used in every single use case that is out there. I'm simply putting top based on kind of like their GitHub stars, how frequently they are updated, and how much popular they are, kind of like that. So, but by no means I'm trying to say that okay, these are the only libraries that exist and there is nothing else. It is absolutely not the case. Depending upon your requirement, you have certain number of libraries which are very good doing at certain things. For example, if you're going to work with a tabular data set, pandas is one of the Python library which is very famous, because it allows you to kind of like have a look at the columnar data and do analysis on that. When you introduce geospatial data in a raw format, which is like an Excel format, then you have GeoPandas. But now when you have a moving data available, then you have moving pandas. So moving pandas is again an extension for pandas, but it is only meant to deal with the moving data set. And that's why it's not the top geospatial library, because it is working with a niche problem statement. The libraries that I'm mentioning to over here are usable in almost every problem statement that is out there. So the first and most widely used is a GeoPandas. So as I said, it helps you to deal with the tabular data and do the spatial operations. So think about it like, for example, if you have worked with Postgres or PostGIS in the past, you might have been familiarized with so many functions being available in in PostGIS, right? Similar kind of functions are also available in GeoPandas because again it is built with Shapely, Fiona, etc. Meaning that you can bring your geospatial data. It doesn't matter if you're dealing with shapefile, GeoJSON, GeoPackage, KML, anything. You can just bring that data and do the analysis on that data using GeoPandas. Now, this analysis can consist of a row-based analysis. So, for example, you have a polygon data and you want to find out the centroid. So, this is something that you can do as a row-based analysis. But let's say if you have multiple files together and now you want to do the relation between two files and find out, whether like you have one point file and one polygon file and you want to find out, how many points are within that polygon, something like that. So these spatial relationships can also be created in GeoPandas. This is also very much possible. And the very amazing thing about GeoPandas is that even if you have one file, which is GeoPandas, which is a geospatial file, and if you have second file, which is just pandas, which can be a simple CSV, you can still merge both of these data sets and create the final output, which will have all the columns from this pandas data set as well. And this is because GeoPandas is again built on top of pandas. So meaning that everything that you can do with pandas, you can also do with GeoPandas, and that's why it is so much famous. Next we have is a Shapely. So Shapely is used for the geometry operations. So as I said, we can do buffer, we can do intersection, we can do union, and so many functions with Shapely. The thing is that Shapely actually creates its own polygon or line or point, and then it does that operations together. So that's why when we create GeoPandas, we actually store the data or that particular geometry in a Shapely format. Then you have Fiona, which is an input output for shapefile and all other vector formats that are out there. So using Fiona, you can read the file as well as after your analysis, if you want to export that file or write that file, you can also do that with Fiona. Then you have a PyProj. So many times I have wasted, like hours and hours figuring out why my script is not working or why I'm not getting the correct result. And just to realize that I was working with a different projection system. And now I have made a promise to myself that whenever I start a geospatial project, I first ask my client to confirm me what is going to be the projection that they're interested in and what is going to be the projection that the input data is going to be, so that I will not waste those hours. But again, the good thing with Python is that you can use PyProj to actually do this conversion very seamlessly. There are so many projection system or coordinate reference system out there that it's almost impossible to like remember everything. But using PyProj, you can actually do this conversion of a single geometry or even the files of geometries in a single click. For example, if you load a data, let's say you have a GeoJSON, you load it as a GeoPandas, then you can just export it with a different CRS altogether. So your original data might be in, let's say, EPSG 4326 and you are interested into exporting it as a 3857. You can do that. Now here is a fun thing. You might be doing this with QGIS or ArcMap or something like that in the past. Think about it like that. If you have, let's say, 100 files, right, and you're dealing with QGIS, now imagine that you have been tasked to actually convert all of these 100 files from EPSG 4326 to something like EPSG 3857. It will be almost impossible for you to do this very quickly with QGIS, because you will have to bring the file, you will have to kind of like click on export and then export it. Whereas with GeoPandas, you can just write a script which will say that, okay, go to this folder. Because you're using Fiona, you can read each one of the file. So you can say that, okay, go to this folder, look for all the files with the extension of .geojson, take the file, load it in GeoPandas, convert it into different projection, and again save it in a GeoJSON format with whatever name that you want to give. And this will be a single script. So once you write that script, it doesn't matter if you're dealing with one file, 100 file, or 1000 files. The script will take each one of the file, render it, convert it, and store it back for you. And these are all the things that I believe are absolutely important for someone who wants to learn, geospatial Python, because we also like have our own courses on geospatial Python, and majority of these times these the people who work with us, or who are taking our courses, they have tried learning Python on their own, but the problem is that they think that okay, Python is too complicated, because there are, of course, there are few things which will make you feel that Python is complicated. But the thing is that if you go ahead with a problem statement in a mind, and that's exactly why I said that, okay, think about a problem that you are doing every single day with QGIS or ArcGIS, and think about how you can automate it. If you take that approach, it will be very much easy for you to learn Python. So this one example that I gave is a very good example for anyone who wants to understand the capabilities of GeoPandas. Another example, what you might think about is, like, for example, India. You can take Indian data. You have all the states available, right? And then you just grab all the airports available across the world, okay, or maybe across the India, and then you write a GeoPanda script which will take each one of these airport, see in which state it is, and then maybe add that state name to that particular airport, right? So imagine how you will do this, on QGIS. Certainly you can do it on a QGIS. It's not impossible. You can certainly do this. But imagine that you have been asked to do this every single day, or you have been asked to do it for all the countries that are available in the world, right? So it'll be too much time consuming, and that's exactly what the focus, that exactly what the aim of using Python should be. You automate your things in such a way that it saves you either the time, so that you're not doing every single day the same thing again and again, or second is improve accuracy. So when we say that improve accuracy, what we mean is that if you try to do it with manually, you might miss some of the data points because you are not paying close attention. But if you write a script, it is going to work 100% of the time, and you will get a very good accuracy. Now coming to the second point, which is a raster data, which is something that we are also working on nowadays a lot, because raster data are kind of like giving you answers to the questions which are not possible earlier. We are working with the clients across the globe where we are answering a lot of things just based on these high resolution satellite imageries. And one of the problems with these high resolution satellite imageries are that they are very heavy. So meaning that the sizes can be anywhere between like 500 MB all the way up to couple of TBs. And in such cases, you have to create systems which can read these files, which can do the analysis, and which can give back the result at a warp speed. And this is exactly where understanding raster data is very important, because again, in raster data as well, there are so many types of things. You have multi-band image, you have single band image, you have netcdf file, you have HD5 files, etc. And then for each of these different types of files, you have different Python packages to deal with, because these packages are meant to deal with particular types of files. So for example, rasterio is one of the kind of like a general purpose thing. So it's equivalent to what GeoPandas is. GeoPandas is kind of like a base level or a base library that you should learn if you want to understand vector data analysis. Similarly, rasterio is something that you have to understand if you want to get into raster data. It allows you to read and write geospatial raster data sets. So very simple thing that you can do, for example, is that if you have a geotiff and you want to first of all understand how many bands are there, and you want to check whether this particular imagery has 3 bands or whether it has 2 bands or a single band. Again, you have 100 of such geotiffs. How are you going to do this in QGIS? Whereas in Python, you can just write a script. Similarly, you can write a script, you can look at each one of the TIFF, read it with rasterio, and get its all metadata. You can get the projection, you can get the transform like bounding box, you can get the number of bands, etc., etc. All of this information you can get at a very, very fast speed. And that's exactly why rasterio is so widely used, because it allows you to read and write raster data at a high speed. Then you have a Rio X array. So Rio X array is kind of like a combination of X array and rasterio. So X array essentially means that when you deal with a multi-dimensional data, so I'll give you an example of a multi-dimensional data. There are a lot of weather agencies which generate the weather data of the entire world every single day. Okay, So if you think about it, you have a geometry of all the countries, right? You have polygons of all the countries. Now you have a one dimension, which is a time, because like every single day you are adding new data to it. And then you have other dimensions which are weather related. So you have mean weather, max weather, median, standard deviation, rain, etc., etc. So you have multi-dimensional data, which means that you have x, y, and time, and then you have these slices of these different indices that are there, like as I said, mean temperature, max temperature, etc., etc. So when you are dealing with these n dimensional data sets, you need a solution which can actually give you the data without having to go through the entire data set. So what do we mean by that? I'm pretty sure you all must be knowing about Sentinel, right? So Sentinel is a good example. Sentinel is generating new image of a particular location, let's say almost every 5 days. So you have Sentinel, which is of your location. Then you have a time every 5 days, and then you have these 13 bands if we talk about Sentinel 2. Now, Sentinel tile obviously is going to be very big. Let's say if I'm interested in only my farm, which is let's say a couple of hectares, right? Imagine that if I want to get NDVI value of my particular farm every single week, I don't want to download that entire 500 MB or 2 GB worth of file, right? I only care about that 2 KB or 5 KB worth of file. So that's exactly where using things like Rio Xarray comes into the picture. Because what Rio Xarray does is it will clip your geometry from the big geometry to your geometry, and then it will look for the time that you have given and the bands that you have given, and it will only fetch that much data. So your 2 GB worth of download now become 2 KB. So imagine, the difference between 2 GB and 2 KB. That's very huge. And that's exactly why Rio Xarray is such an amazing tool. I actually wrote a blog about it a couple of days ago. Let me actually try to put that link so you guys can have a look at it. PyStack and ODC. Yeah. Yep, this is the one. So this actually talks about how you can get the Sentinel data within a couple of seconds using Python. And this is really interesting because when I was looking or doing research on this particular thing, this made me realize that how much easy it is nowadays to procure these imageries. And that's how exactly the idea for the Observe Earth was born, because it is very difficult. Like if you ask let's say a non-geospatial guy, that we want to procure farm imagery every 5 days, this will require a very big infrastructure. Whereas with our APIs, we were able to do these things for you so that you just give the area of interest and you will get the imageries back. Then you have Xarray. So as I said, handling multi-dimensional arrays. So for example, NetCDF is a good example of this. NetCDF files are generally created for weather or climate related stuff, where you have geometry as well as multiple dimensions, and you want to deal with it. So Xarray is, so Rio Xarray is kind of like a child of Raster Rio and Rio Xarray, because Rio Xarray also allows you to expose the data and export it or write it in a GeoTIFF or any other format. Then you have a NumPy. So why NumPy is written over here is because if you think about it, pixels or the values that are stored in a pixel is nothing but the numerical data, right? So if you think about RGB images, what it means is that pixel consists of 3 values, R, G, and B, each varying from 0 to 255. So at the end of the day, this is all numerical. And that's exactly why you also want to be familiar with NumPy, because NumPy will allow you to do mathematical operations on your pixel. So let's say you got the imagery of your couple of hectares of farm. Now you want to find out the mean value of your NDVI, or maybe you want to find out which is the particular pixel where the vegetation is not good or very good, anything like that. All of this is at the end of the day a numerical data. So using NumPy, you can perform all of these operations. Now, apart from raster and vector data, we also have to take care of visualization. Now, when it comes to visualization, Python, I would say that it's not the ideal tool, because Python is meant to be run on a backend or on a server side and not on the client side. But still, let's say if you're doing some research and you want to create some kind of visualization, there are of course tools available. So for example, matplotlib. So again, what GeoPandas is for vector data, matplotlib is for the visualization. It's again a go-to tool which understands the geospatial data as well. So if even if you have a GeoPandas, let's say even if you have a GeoPandas data frame, let's say of all the countries in the world, you can just see it on a map using matplotlib. But this will be a static map, so it's not an interactive map that you will get with open layers or something like that. Then you have other things like Cartopy is also one of them. One of the reasons why matplotlib is so famous is that it allows you to change a lot of things on the fly. You can create production grade very good looking maps using matplotlib. You can control the legends, you can control the styling, you can control whether you want this x and y axis or whether you want a gridded version or not, etc, etc. There are so many things that you can do with matplotlib. Then you have a Folium. So Folium actually allows you to put the interactive maps in your notebooks. So people who don't know notebooks, so essentially in Python there is a concept known as notebooks, which allows you to kind of like create a blocked version of your Python code so that you can run any Python code and just that piece of Python code. So you can actually load this Folium map using leaflet, which is a leaflet based map in your notebook. And then this will be an interactive map. So meaning that you can add layers to it, you can click on it, get information in pop-up, etc, etc. Then you have IPy leaflet, again something as an alternative to Folium. And then you have a Kepler GL. So PyDeck is another interesting library which is GPU accelerated. So if you are dealing with a big data, couple of GBs or even like a couple of hundreds of megabytes, you need a solution which will load the data very fast. And that's exactly what the PyDeck is all about. If you know DeckGL, it is a library that is being maintained, and it was actually brought to the life by Uber. And the reason was that they were looking for a GPU accelerated visualization tool which can show big data at a very high speed. And PyDeck is essentially the Python binding of that. Then there are other things also that I wanted to talk about. Because we are also dealing with these things, and I believe that even though there are very small use cases, it is still important for us to know. If you deal with point cloud data, you have to get familiar with the PDAL, which is like a GDAL, but it's a point cloud data abstraction library, which allows you to process the LiDAR as well as point cloud data, and you can run it on a terminal itself. So PDAL allows you to do things like convert the data and do the abstractions with the data. And then there are libraries like Open3D, which allows you to do the processing and the visualization. Now, point cloud data itself, again, as I said, the data itself is not going to make a lot of sense, but what you do with that data is going to make a lot of sense. So for example, let's say you have a categorized data of the point cloud and you are interested into, let's say, finding out the canopy girth or canopy height. Now, then you can use this PDAL, Open3D, these kinds of libraries to deal with your point cloud data, convert it into DEM, DSM, DTM, etc., and then run the watershed algorithms, etc., etc. on top of that. Then the next important thing is a big data management, because as I said, like we have been bombarding with petabytes of data every single day. So we need a solutions which can help us to also do this computing of a big data at a warp speed. So Dask is an amazing framework to do that. It allows you to do the parallel computing on large geospatial data sets. The good thing about this is that you can also use the hardware providers like Azure or AWS, so that you can run the Dask parallel computing on that particular GPU machine and then just get the result. So essentially you will be only charged when you turn on this Dask parallel computing machines, run your script and then get back the results. We have done something like this with Observer, where we are dealing with a like very high resolution imageries where we need to do parallel computing. So to do that, of course, we are not going to have our own or like buy our own GPU enabled machines, but we can always rent them, like how we do with AWS, EC2, etc., etc., right? So you can use this Dask framework to actually do that parallel computing. Then other things that we also have to understand is about the data formats. So far we have been storing data in GeoJSON, GeoPackage, shapefile, etc., etc. But then there are also these cloud native formats like GeoParquet is one of them, PM Tiles is one of them, cloud optimized GeoTIFF is one of them, which are meant to be used with the cloud systems more and more. So what I would recommend is that whenever you're dealing with the big data, also try to understand that what might be the correct format for you to store this data. So for example, if you're going to deal with static data, static vector data, it makes sense that you can convert it into a PM tiles and then just host that PM tiles on something like Cloudflare R2 or AWS S3 and then directly use it. By doing that, you are actually using the vector data without a database. So your data is stored on a cloud storage and you are directly using it on your web application. And as I said, like ZAR is also one of the formats which is very famous in the raster world of the geospatial data. Now let's understand the modern GIS workflow, like how exactly we should think about a problem statement and the solution for that problem statement. So the first question always is that the data collection. How are you getting the data? Are you getting the data within API or whether it is a remote sensing data that you are getting from Sentinel, Modis, for example, with Observer, our API service. So your data collection actually defines that what all tools you are going to use. If your data is going to be in database, you need to use a Python library which is very much familiar with the database that you are using and then and has a correct binding. For example, if you are storing the data in PostGIS, you can use GeoPandas and use like read PostGIS function to directly read data from PostGIS. You don't need to write any other code. So that's why understanding the data collection is very important. Then next you have is a pre-processing. So pre-processing generally means that you have to do reprojection, clipping, masking, etc. So I'll give you an example. So when you are dealing with let's say machine learning algorithms on satellite data sets, your satellite data sets are going to be quite big, like 5 kilometer by 5 kilometer or 50 by 50 kilometers, which means that they are very big in size. Whereas the general hardwares will not be able to run the machine learning model on this entire GeoTIFF in one go. So in that case, what we do is we actually clip this GeoTIFF into smaller portions, and then we run the model, and then we again kind of like reclip it and make it as a one big GeoTIFF. So these kinds of pre-processing you have to do depending upon your own use case. Then you have analysis. So analysis can be again vector or raster, and finally it's a visualization. So as I said, like if I want to show, let's say, all the farms which are performing very bad in the vegetation, I will have to show it on a map or something like that. Like I cannot just say that okay, in this entire 2000 hectares there are 50 hectares which are not good. This particular statement will not bring any kind of like any kind of sense. But if I say that okay, if you go to the northwest corner on this particular lat long, this particular farm is not performing very good, this is something that that makes sense. So having that visualization is very important. And last but not least is that automation. How can you do something that you are doing today in an automated way, so that tomorrow if you are asked to do the same thing, you don't have to spend the same exact amount of time again. This is very important, and I believe that this should be the starting point for anyone who is interested into understanding the GIS. Future pathway. So like someone who wants to understand what is the future of Python and GIS, so let me tell you that it's really amazing, because as the world is also moving into the AI, your geo AI is going to be helpful, and more use cases will come up, because for last couple of years there is a vast amount of raster as well as vector data that is being generated across the world. So you have raw data to your hand, and all you have to do is understand the machine learning, understand how to utilize that data, and you can create your own models. Then you have a cloud GIS. So as I was talking to you about this in the beginning, that think about all the installable software based work that you are doing. Maybe it will be with ArcMap or with QGIS or anything like that. Sooner or later that is going to go away, and it will be cloud oriented, which means that you will not need to install certain kind of things on your machine to run it. You will be able to run this cloud these algorithms or let's say these workflows even from your phone, because everything will be available to you on a cloud basis. And that's exactly why understanding Python is also very important, because when you are doing everything on a cloud basis, essentially you're being charged for, let's say, the automations or for the workflows or the functions that are running. So how do you optimize those in a such a way that your machines are not engaged for a long time? How do you schedule your task? How do you create your pipelines? Really is going to make the difference. And last but not least is a WebGIS. So like, how can you combine Python with other like ecosystem, like for example open layers or leaflet, in order for you to consume this data that you're generating, or functions that you're working with in the back end, to be shown on the front end. Now, if you are interested into getting started, there is this entire workflow of the workshop available. So I along with a lot of other people conduct these GeoPython workshops in a FOSS4G events internationally, and we have this this entire notebook available. This will be actually going this is live. The next version of this is coming on a 14 July, where some of our team members will be in Europe presenting this workshop. But if anyone is interested, you can just go to that the link that I have given for this presentation and click on the start here button. When you will click over here, you will go to this GitHub page. You'll go to this GitHub page, and over here you will see this binder button. So just click on this binder button and you will be launched binder, where all these workshops and everything will be available. So that's all that I wanted to present. If you want to connect with me, you can find me on YouTube with the name Krishna Lodha, or you can always write me an email as well. Before I end the session and open the floor for the questions, I had few announcements that I wanted to do. Let me share the full screen for that. Just give me a moment. So those who are interested into Python and other geospatial thing that is going on, if you have heard about FOSS4G, FOSS4G is world's biggest free and open source for geospatial conference, and they have again the chapter. So there is a Asia chapter, and we were fortunate that the FOSS4G Asia 2026 is going to happen in Nasik. And I am really excited to let you guys know that I am essentially the leading body, and Nasik is my hometown. So I actually I submitted a bid to do this FOSS4G in Nasik, and fortunately we won the bid. So I'm very excited to have this event, and this is going to be an amazing geospatial developer first event, where these are all going to be the talks and workshops related to development. This will obviously have Python and a lot of talks from the people across the globe about Python, about machine learning, about the front end frameworks, databases, middlewares, etc., etc. Everything geospatial. So if you're interested into attending, feel free to register your interest. If you're interested into speaking, you can definitely also register your interest for that. Our speaking calls, like call for submission, will start on 15th of July, and we are really excited for this to happen. This is going to be a 5 days event, where like it'll be amazing. Believe me, like this is something that has not happened in India for last 9 years. So this is like, I'm really fortunate that I was part of the team who worked into bringing this. So I'm not sure, were you guys able to see my screen for the FOSS4G? You were able to see, right?
Yes, yes,
Yeah.
sir.
So I'll just put this link also. And the last thing is that if you are interested into learning more about the GeoPython, we have an ultimate GeoPython course, which is more than 50 hours of content, which contains everything like introduction to Python, vector analysis, raster analysis, visualization and cartography, building WebGIS application, Python and ISRI, Python and QGIS, Python and Google Earth Engine, spatial databases and big data workflows, point cloud and 3D analysis, machine learning, everything. So essentially, this is a self-paced course. So you only pay once, and then you have access to it for the lifetime. So if someone is interested, you can also register your interest over here. So that's a lot from my side. Again, thanks a lot for inviting me. I'm open for questions if you guys have any.
Yes, if anyone has questions, you can ask directly through mic, or you can obviously uh, chat in the chat box. And if you have any questions regarding it. And thank you, sir, for the wonderful insights.
Yeah,
I mean,
yes.
I've myself learned a lot
Yeah, I hope
because of my
it was useful. Yes, thank you.
yeah.
Yeah, I see there's one hand raised. So yeah, Umair, do you want to
It's
go ahead?
Umair Ahmed. Please.
Good evening, sir. My name is Umair Ahmed, and I have just completed my PG diploma from Jamia Millia Islamia in Remote Sensing and GIS.
Okay.
Sir, like it was very interesting lecture, and I want to understand something like someone who have not yet explored the whole things about software like ArcGIS, QGIS, and ArcGIS2. And then we see things like Python, AI, and machine learning. So sometimes it becomes confusing for us that should we just explore the software first about every tools, or we should totally go in the Python and machine learning. Like someone with that confusion, how we should approach these topics, like
Yeah,
what
it's an interesting question. So essentially, there is something known as tutorial hell. If you are familiar with the concept, if not, then I'll tell you. So essentially, if you pick up or if you think about, okay, let's say I want to learn Python. Okay, if you just go and if you search on YouTube, you will get like million results, and then you will watch one video, you'll try to do that, and then you'll be like, okay, but this guy has another video which is on another topic, so maybe I should also learn this. And once you watch that video, then there will be a third video, then there will be fourth video, and then before you realize, you are in a hell. And that's exactly what is known as tutorial hell. The one way to avoid that, what I have understood now, because I am also learning the machine learning thing on a greater level now. One thing that I've realized now, that the strategy that I take is that I always take a problem statement first, and then I try to find out that, okay, if I want to do this, what all things I need to learn, and I will only learn those. I will not learn the entire thing. So for example, in your case, since you are saying that you have not gone through QGIS, ArcGIS, ArcGIS Pro, or even Python for that matter of fact, uh, the first question that you should ask to yourself is that, okay, what is something that I want to do? Forget about tools, forget about this programming language or anything like that. These are all these all choices you should never do in the beginning. And uh, that's exactly what a lot of these I would say freshers do, that they try to give more weightage to React or to Python instead of going with the problem statement. So think in a direction that, okay, you might say that, okay, I want to do this where I have, as I said, like you have a folder with 100 shape files, you want to convert them into GeoJSON. Now you have a problem statement in front of you. Now you try to ask Google that, okay, how do I do it with QGIS, or how do I do it with Python? So that you will only learn those particular things, because any software you pick up, there are thousands of features. It's impossible for you to learn, or anyone for anyone for that matter of fact to learn. So take that approach of a problem statement first. Think about yourself, think about it yourself, that what do you want to do, and do that reverse engineering. So I think that's one of the approaches that we find interesting. So yeah,
So all the
Sahil. Yeah.
participants,
Yes, sir.
so all the
Hello.
participants are requested to kindly fill up the feedback form not to get the certificate. And please, Sahil, continue.
Yeah, thank you for the opportunity. Actually, I am a fresher in this JS field. I just joined the last year. I don't have actually a proper knowledge that what is the scope in this field if I learn the back.js or the right now I'm working on the ArcGIS desktop. But if I switch to back.js, then what is the scope? What is the future possibility and the highest package, something like that? Any info on that?
That's a interesting question. So I get this question almost every single week on my LinkedIn. And yeah, the reality is that I also cannot comment on this question. Reason being that I think it's the same for every single field that you pick up. For example, you have civil engineers who are, let's say, who are working in 5,000 rupees a month, and also someone who is doing, let's say, 5 lakh a month. It's all a skill set that you can bring to the table. What I feel as fortunate working in the geospatial field for myself, what I feel is that geospatial is something that is being used in almost every single industry. So if you are working with the correct people, there's always going to be the work. So for example, if you consider India, the biggest buyer of geospatial services in India is obviously government itself. And if you think about it, government is a client which will never run out of money. So there will be always projects available with governments with geospatial. We are working with we are working with so many departments which I never thought that they will also need a geospatial service. So for example, we are working with department whose job is only to provide the softwares to dams and underground water bodies, but underground. And it was such an amazing thing that when we started working with them, to realize that okay, like people are using geospatial in so many different places. So what I would say is that you probably need to think about the niche that you want to go in geospatial, and then try to focus on that. Like for example, every single department that you pick up, in every single department, urban development, there is a GIS. If you do smart city, there is a GIS. If you do electricity board, there is a GIS. Water board, there is a GIS. It's just a matter of fact of finding the right work. That's what I would comment on.
Sorry, one more question. If I talk about my friends, today technology, like my all the friends from my college are working in the artificial intelligence, some are web developers, machine learning. There is a technology, and there is a scope. When they tell about their jobs, it seems like they are going at a right in a right direction. But
Correct.
when they ask me what is your job profile, I just say IGIS. They
Hmm.
don't know, and I am not sure about it.
Yeah,
So
no.
I
So I will tell
just
you,
want a direction that I am in
I
the right field.
so basically I'm a civil engineer. I never heard about geospatial. Even when I graduated, I was working as a civil engineer for 2 years. So I came to know about geospatial in 2017. No, 2018 actually, 2018. But I agree to that. If they are working in artificial intelligence, they are going in a very correct direction. And that's exactly why you should also learn Python and get into the AI, because now you can actually do, see, essentially AI is going to be AI. If you use it in GIS or even not in GIS, the core underlying concept is going to be same. Someone who is a Python developer can work with the geospatial if only he will need to learn the geospatial related packages that are out there. That's all. So it's not like the Python for GIS is different and Python for other industries is different. If you learn Python, you can jump into any industry, whoever is using Python.
Thank you.
Next question.
And see, you have a question, you can ask.
Okay, that's a good presentation, Krishna. I really enjoyed it. Thank you, thank you. So I have two questions. The first one is about the, let's say let's say someone is saying I don't know programming, so the AI and the ChatGPT, of course, is doing a good work. Now my worry is if you rely mostly on ChatGPT, of course you must understand the behind scenes of the programming
Absolutely.
language. Yeah, so
Absolutely.
my worry is if you really use the ChatGPT, sometimes you need to code, like natural code, you need to code, right?
Yeah.
So my worry is that because sometimes ChatGPT usually gives some can actually destruct your code.
Yeah.
So how can I advise on that? Then my second question is, apart from Python, there is other languages, that is R, there is a JavaScript. So like on my end, I've been using JavaScript for quite some time. So
Okay.
when I tried to do Python and also R at the same time, I got confused. Like the languages, so it means that I only needed to do one at a time. So I cannot go on that. Thank you. That's my question.
Yeah. So if I understood correctly, your question is that should we learn one language at a time? Is it what you wanted to ask?
Sure.
Yeah, I think that's a good approach, because it can get overwhelming even with the React. Let's say JavaScript world, there is a new framework available every single day. So you write a code, you go to sleep, you wake up, you realize that whatever you have wrote is a thing of a past, and it's frustrating. Same thing is with the Python as well. So don't try to learn everything in one go. Try to take a problem statement and then just learn for that particular thing. Now that you said that you're working with JavaScript, that's good. So for example, you can think about it like, okay, I can show my map, let's say with JavaScript, and I have my data in Postgres. How can I use Python to take that data from Postgres and show it on my map with, let's say, with converting that data into GeoJSON or something like that. That would be a good way for you to start that. I would recommend checking out Django and GeoDjango for this particular thing, because I personally love Django. It allows me to write JavaScript, Python, everything in a single code base, and it's a homogeneous product, which means I take care of views, like I take care of functions and logics and all in Python, and I write front end code in JavaScript, which is ideal case, So I would recommend that don't try to do everything in one go. Try to take a problem statement and try to solve it like that. Yeah, next.
Okay, so Ankan, you have a question.
Sir, thanks for the presentation. So I have a question. I am an undergraduate student, and currently I am doing some project works, and while doing so, I am using some softwares. But to handle the large amount of data, as you have mentioned, we need automation. So I have come up with a problem statement, and I am just doing and exploring some of the stuffs in um, G and R, and also that of Python. But when the problem statement is too complex, how can we short it down or cut it down in pieces so that we can add it up in the future and we can solve that easily, instead of taking the whole big problem statement and trying to solve it in one go? Thank you.
Yeah, actually this is a very interesting thing, and if you can, like, someone who can answer to this question can call themselves as a senior engineer. So there is no, so what I'm trying to get at is that there is no simple or straightforward answer to this. It all depends upon problem statement to problem statement. But I'll tell you for sure, whenever I work on any problem statement, I just put my computer aside, I take a pen and paper, and I try to figure out that what I need to do. And believe me, like, it's such a silly and simple thing, but it saves an hours and hours for me, because for example, in the same case, like where we wanted to, we are essentially trying to do the vegetation indices of the entire state. We want to do it at a very high speed, so that if you say that, okay, I want to see a particular farm in Maharashtra, you should be able to go over there and you should be able to see it within fraction of seconds. This is a very simple problem statement to think about, but there are so many steps involved. And because I have written it down all on paper, I can focus on each particular step and then just only focus on that and figure out that what is the optimum way for me to figure out this step. What is the data format that I'm getting the data in? What is the data format that I have to expose this data? And what is going to be the analysis? Whether there is a better solution or a better library available only for that one particular, I would say sub problem statement. So I think that is one approach that I find useful.
So thank you. Orunima Dasgupta have posted a question in the chat box that I am interested in urbanization. Where can I learn the skill set relevant to this field?
Yeah, I think now, like, for us, it's like we are living in a world of ChatGPT. The best thing you do is you go to ChatGPT, tell them that you know a bit of a GIS, you're interested into urbanization, and also want to learn Python. Suggest some of the ways, or maybe some of the research papers, and I think ChatGPT can give you this. Personally, this is what I also do. Whenever I'm working on a problem statement, I'll just go to ChatGPT and at least do the cursory research, so that it will save me those couple of Google searches that I will need to do in the beginning, just to wrap my head around the problem statement. So I would recommend that you should go with ChatGPT, at least get the keywords sorted. So when you go to urbanization, for example, maybe ChatGPT will tell you that, okay, urbanization means that you have to take care of land use, land cover changes happening over the period of time, or maybe finding out heat islands. Now when ChatGPT will tell you that, okay, you have to do time series analysis of land use, land cover, then you will start thinking about that, okay, how do I procure Sentinel data or Landsat data or Modis data, whatever, on a periodic basis using Python. Then how do I do land use, land cover based on that? Once I get land use, land cover, how do I compare two land use land covers together and find out the changes happening. So now you got steps, and now your first step is to download the data. Now you know that, okay, I want to download the data for the entire city, which is Sentinel. Maybe I will use Rio Xarray because that is the package for that. Second is doing land use land cover. So now I want to kind of like get the value of these pixels and then do the classification. Maybe I will use machine learning. Then third is just the comparison. So then I can just use raster IO. And last is actually to expose this land use land cover in a geospatial format. So maybe I will use GeoPandas. So 4 problems and then 4 solutions to it. So that's the approach that I would ideally take in such cases.
Sir Sanskriti, I have a question. Sanskriti, you can ask the question.
Hello, sir.
Hi.
Right now, I'm working on a problem statement. I'm a master student and also a civil engineer by background. So, thus, I'm beginner in a programming world. So, my problem statement is I'm dealing with the SAR data and creating a geospatial pipeline where the output will be the mapped water surface areas.
Hmm.
So, for this, my question is, the course you mentioned, will that help me, and how will that help me if it works for me? Because as you mentioned that I am also stuck in the tutorial hell,
Yeah.
so so I want to get out of it.
So yeah, so essentially the idea what I'm trying to bring with this course is, if you check out the link, you will see mini projects available. So the idea would be that we will teach. So essentially mini projects also consists of these small steps that you have to take. Each one of these steps is actually going to be the topic that you will be learning in the previous videos. So what I found out is that like even if you want to learn Python, a single lifetime is not enough. Believe me, it's that much vast. So what the best I can do is I can tell you that, okay, this is a problem statement, and how I will think about solving this problem statement, and then what all concepts or what all things we need to learn in order to solve this problem statement. If I enable you to think in that direction, next time when you have a problem statement, you know that what is your thought process or what is your framework of thinking about this should be. That is the end goal. Because like, of course, 50 hours or 45 hours are nowhere near of being calling yourself as a master of Python. There are thousands and thousands of other things, but during those 50 hours, my job is to actually teach you, first of all, these basic concept, of course, but more importantly, how to think like a programmer. Once you do that, then you're on your own. Then you will not need anyone else. Then you and ChatGPT can just take the world forever. So that would be the concept. Similar to similar to this GeoPython, I also have another course on PostGIS. Actually, if you have seen my Udemy course, that's been bought by more than 4,000 people now. But that was a general purpose introduction to WebGIS. So it had PostGIS, it has GeoServer, it has open layers, little bit of PHP. It was a general purpose course for anyone who wants to understand what the hell is WebGIS altogether. And now I am creating this full length, very deep courses where I'm teaching concepts as well as the framework, the teaching, the learning framework. So essentially, I have PostGIS, which is also there. I have a GeoPython. I'm working on 40 hours GeoServer deep concept. So if you have been following me on LinkedIn, few months ago, I did like a 10 people cohort on GeoServer, which was very huge. Like it was 40 hours of intense GeoServer. We used to sit 2 hours every single day. It was only 10 people, and the material was amazing. Like people absolutely loved it. We have people from Survey of India, we have people from Airport Authority of India. They absolutely loved it, and that's why I decided maybe I can make it as a self-paced, because 2 hours every single day for like 4 weeks, it's too much. It will just fry your brain. So that's where these courses are being and at the moment, the reason why you see the prices as less is because they are not completely available on the site, because I am still creating a lot of content, and that's why I'm giving these courses at a lesser cost right now. But once the courses are done, then they will be sold at the full price. So if you guys are interested, you can certainly buy directly, or you can drop me an email, and then I can help you to get it done.
Thank you, sir. I'll be looking forward to it.
So I think that's are all the questions.
Yeah.
Thank you, sir. We will be
Yeah.
closing. So thank you all for joining for today's enlightening session under the Geoverse lecture series. It's been an incredibly insightful journey into the evolving world of geospatial technology. A very special thanks to our speaker, Mr. Krishna Lodha, for taking us through the transformative landscape of GIS powered by Python. Your clarity, depth of knowledge, and hands-on perspective truly brought the topic to life. From automation workflows to real-world case studies, your session has sparked inspiration and offered immense value to every GIS enthusiast present here today. Your passion for open learning and your commitment to building vibrant geospatial community is truly commendable. We are grateful for your time and expertise, and we hope to collaborate with you again in future. To all your
Absolutely. Look forward.
participants,
Yeah.
thank
For-
you for your active engagement. Yes, sir.
Thank you. For those who are not connected with me on LinkedIn, feel free to drop me the connection request, and you can also take a screenshot of today's lecture and maybe post it on LinkedIn and tag me. I'll be more than happy to repost.
Yes, sir.
Thank you. Thank you all. Bye.
Thank you. Thank you.